Welcome to another edition of Math for No Reason. In this edition, we are going to prove this inequality, which states that if we have n numbers which are lying between 0 and 1, and Sn is the sum of these numbers a1, a2, an, then 1 minus Sn would be less than the product 1 minus a1 into 1 minus a2 into 1 minus an, and which would then be less than 1 by 1 plus Sn. N here is assumed to be greater than or equal to 2. Now we will prove this using the method of induction. So we start with the case when n is equal to 2. So we are going to prove this result when n is equal to 2 as a first step. Now note that 1 minus a1 into 1 minus a2, if you look at this and expand this, this becomes 1 minus a1 minus a2 plus a1 into a2. Since a1, a2 are both positive numbers, so a1 into a2 is a positive number. So this is greater than 1 minus a1 plus a2, which is equal to 1 minus s2. So this proves that 1 minus s2 is less than the product of 1 minus a1 into 1 minus a2. Now observe that if you look at 1 minus a1 square, you can write that as 1 minus a1 into 1 plus a1, and 1 minus a square, since a1 square is positive, is actually less than 1. So 1 minus a1 into 1 plus a1 is actually less than 1. So we get from here that 1 minus a1 is less than 1 by 1 plus a1. We can do the same thing with a2, and we will then get 1 minus a2 is less than 1 by 1 plus a2. Now taking the product, so 1 minus a1 into 1 minus a2 is less than 1 by 1 plus a1 into 1 plus a2, and if we simplify that, we get 1 by 1 plus a1 plus a2 plus a1 a2. Now a1 a2 is a positive number, so if we omit that, that quantity will actually be less than 1 by 1 plus a1 plus a2, which is 1 by 1 plus s2. So we have done it for the case n is equal to 2. Now let us assume it to be true for n is equal to k, and we will then prove it for n is equal to k plus 1, and then by the principle of mathematical induction, we will conclude that this inequality holds for all n. Let's go to the case n is equal to k. So assume 1 minus sk is less than 1 minus a1 into 1 minus a2 into 1 minus ak is less than 1 by 1 plus. We will prove the result for n is equal to k plus 1. So to do that, let us work with 1 minus a1 into 1 minus a2 into 1 minus ak into 1 minus a k plus 1. Now we know that 1 minus a1 into 1 minus a2 into 1 minus ak by the induction hypothesis is greater than 1 minus sk. So the final quantity is greater than 1 minus sk into 1 minus ak plus 1. Expanding this, we get 1 minus sk minus ak plus 1 plus sk into a k plus 1. Observe that sk into ak plus 1 is a positive quantity. So this quantity 1 minus sk minus ak plus 1 plus sk into ak plus 1 is greater than 1 minus sk minus ak plus 1, but sk plus ak plus 1 is sk plus 1, so this is greater than 1 minus sk plus 1. So one part of the inequality is proved. For the other part, we observe that 1 minus a1 into 1 minus 1 minus ak into 1 minus ak plus 1, this quantity is less than, again using the induction hypothesis, 1 by 1 plus sk into 1 minus ak plus 1. Now remembering the same trick that we had used earlier, so 1 minus ak plus 1 square is less than 1, which means that 1 minus ak plus 1 is less than 1 by 1 plus ak plus 1. So therefore, this quantity is less than 1 by 1 plus sk into 1 by 1 plus ak plus 1. Now this is 1 by 1 plus sk plus ak plus 1 plus sk into ak plus 1. Now sk into ak plus 1 is a positive quantity, and if we omit that from the denominator, what we get will be a larger quantity. So this is less than 1 by sk plus ak plus 1, which is equal to 1 by sk plus 1. Therefore, by the principle of mathematical induction, we can claim that this inequality is true for every n where n is greater than or equal to 2. Thank you.